Hey kiddos, hope you're doing well. I'd like to continue to dive into these problems, word problems, and encourage you that you can do it and validate sometimes they're not that easy, but there are certainly some strategies that I think will help over time. So continue to be gritty, resilient, try different things, and feel comfortable asking for help for now so you better understand how to do these things. So here's a problem below, and what I would like to do is kind of take you through this problem and then go through the problem itself and then outline some, what are some general strategies that might help moving forward. So take a minute to read it. Isabel should walk in a walkathon, and basically she's walking slowly at first, and then she jogs, and we have little information about the distances for each leg. She finished within 2 hours 15 minutes. The question is, how long was the course, right? And here's a little hint which makes it a little bit easier. Okay, so I guess the first problem solving strategy is to understand what we got and what we want, right? So here's what we got, right? So far we got a lot of information about how Isabel was walking and jogging, right? What we want is to figure out how long the course was, right? And so that's a little deceiving. So we're trying to find the distance, right? How long the course was. We're looking for the total distance. Now, something that I understand about this problem is that there are two legs, right? So my next step is to kind of, I call it frame it, right? I want to think big picture, like what on earth is this coming down to, right? And so for this particular problem, since I know how long it took for Isabel to walk the total, right, I'm going to use time, right? And so the framing piece now I can do, and I know that the total time is equal to the time of the first leg plus the time of the second leg. Does that make sense? And again, I know there are two legs, right? A walking leg and a jogging leg, right? There are two pieces that add up to be the total 2 hours and 15 minutes, right? So basically my framing is that, okay, the 2 hours and 15 minutes it takes for Isabel to finish is basically made up of the first time, which is the walking piece, plus the second time, okay? And again, I'm basically moving off of this hint, right? And thinking in terms of time, even though I'm looking for distance. Okay? So, there's my frame. So the next piece I want to do is to kind of finish. Right? For those of you who are into construction, which is one thing I wish I could do, but can't, I'm not very handy, though I'm trying to be, is once we have a framing, right? So think of the construction of a building. You frame it, and then along come the people that do the drywalling and the electricity and the plumbing, the finishing, right? So now it's time to, quote unquote, finish. And by that I mean, let's get particular. Right? Let's quantify things. Right? So I really want to quantify this kind of overall frame. Right? So total time is easy to quantify. Okay? However, there's a little trick. Right? I'm talking about miles per hour here, miles per hour here. So I don't really want to call that 2 hours and 15 minutes. So the question is, how many hours is 2 hours and 15 minutes? That's correct. It's 2 1/4, right? So the total time I want to look like 2.25, right? So now I'm quantifying. I'm kind of substituting. I'm thinking about what's a better way of saying 2 hours and 15 minutes, right? And based on the way the other rates are labeled, miles per hour, that's where I'm taking 2 hours and 15 minutes to 2.25 hours, right? And I'll keep my labels for now. Okay? Now the time of the first leg, going back to the hint, is going to be distance over rate. Distance over rate, okay? Well, that's easy enough. So distance over rate, the distance is, let's just say this distance is x. So one thing I also want to do, in order to quantify, I have to define my variables. Right? In order to do this piece now, I need to define what the heck my variables are, right? So that's going to help me keep organized. So at this point off to the side, I'm just going to say let x be what? Well, let's just start here. Let x be the distance walked, Fair enough? Okay. So if x is the distance walked, then the time of the first leg I'm going to replace with distance over rate, right? Now remember, I called the distance x, and the rate for that is 5 miles per hour. Fair enough? Now the labels are starting to get messy, and I actually, to be honest with you, I'm going to erase them in a second and then put them back at the end. Okay? Even though this probably shouldn't do that, it just makes the solution piece a little bit better. So if x is the distance walked, right, that's going to help me now quantify the second piece, right? Well, the time of the second leg using distance over rate, right, is going to be, well, what's the distance for the second leg, the jogging leg? Well, twice the distance that I walked. Isabel, if x is the distance walked, then the distance for the running piece, the jogging piece, is going to be 2x. Right? So that's the distance for my jogging leg. Then I'm going to divide that by the rate that I was, or Isabel was, running, miles per hour. Okay? So now I got something nice. Let me clean this up. Okay? So I've defined my variable, and by doing so, that allowed me to create an equation. Okay? And this is where some of us got stuck. It needs to be a solvable equation. And it needs to be accurate. It needs to make sense, etc., etc. Okay? And I think it's by framing that I can make sure those things happen. Okay? So I now have my equation, and I'm going to clean it up right now. And the equation, to make it look a little prettier, is going to look like this, right? 2.25, that's the total time it took for Isabel to walk, is equal to the time of the first leg, which is x over 5, distance over foot rate, 5 miles per hour, right? Plus the time it took for the jogging leg, the running leg. And that's going to be distance over time again. But in this case, since Isabel ran twice the distance as she did walk, the distance piece for the running leg, the second leg, is going to be 2x, and the rate for that leg is going to be 8. Okay? So now I have a solvable equation, right? It makes sense. The total time equals the time. Time is represented as distance over rate of the first leg plus the time it took for Isabel to run the second leg. Right? Running leg plus walking leg time equals total time. That makes sense. Okay? Of course, the last is to solve equation. And don't forget about your labels. Okay? So now I'm going to solve this, and I'll leave that up to you. Right? How do we? Well, actually, I won't. I will do it. One thing some people like to do is to clear fractions, and I'm going to do that right now. And to clear fraction, I'm going to multiply everything in this equation by the common denominator, which will be 40. Right? So when I multiply everything by 40, I multiply the left side by 40, which gives me 80 plus another 10, another fourth of 40, that gives me 90. So this becomes 90 when I multiply both sides by 40 equals, when I multiply x over 5 by 40, I get 8x. And when I multiply 2x over 8 by 40, I get 10x. Okay. And now I'm going to combine terms. I get 8x plus 10x, of course, is 18x. And then I divide both sides by 18, and I get x equals 5. Okay? And so what that means now is, okay, that's the distance walked. So that's how many miles we walked. How many miles do we run? Well, twice that. 10 miles run. Okay. So therefore the answer, how long is the course? Well, if we walked 5 miles, if we ran, Isabel, 10 miles, then the answer of the question is, the course therefore is 15 miles. Okay. Now, here's my answer. I'll leave it to you to check. We'll talk about tomorrow how we can check if you're not quite sure how to do that. But let's kind of reiterate here, kind of how I would solve this. All right? Understand the problem, right? Frame it in a general sense. Some people like to use a chart for this. We'll go over that tomorrow. A chart is a good way to frame. Then we want to take that general framing and get particular, quantify things, okay, name things. Of course, it's easiest to do that after we've defined a variable, so that might go first. And then once we have kind of the particulars and the variables, we want to use those to make an equation that makes sense, that's solvable. And of course, then we solve that equation and label. Okay? So here's my solution to this word problem. And you guys can do it, right? Some general strategies are as such, but in addition to that, there are some dispositions that are helpful, right? Some like patience, like grit, perseverance, etc., creativity, the ability to be resourceful, right? There are lots of pieces in here that go. Okay, but for now, take that for what it's worth. That's a good problem for you to think about, and some general strategies in addition that come along with that. Lots of different ways to approach this. I'll show you some chart stuff tomorrow. Okay, your homework for tonight is to do one problem or two problems. I'll assign it. Thanks for listening. Bye-bye.